in any context.
Hit C or something?
Oh no, it doesn't do anything.
I forget if it's because it's on you're doing a file colon and not a loop back.
Well, it was doing it when I wasn't in presenter mode. I'm
okay.
also amused that I get the presenter mode with the like menu barless window, but like the actual presentation window gets to see all my bookmarks.
Yeah, I know. I usually run under Chrome too. But,
this is Chrome.
Oh, weird. Anyway, if you want to play around with that a bit, it's definitely the slides are advancing, so
yeah,
it's mostly going to be us talking.
I don't care. It would be cool if I could figure out how to hide the bookmark bar.
Control B.
This is
Chrome.
You'd like to think that way.
Control Shift B.
Oh, great. Thank you.
Oh, and now you get the rounded corners, so it's closer to like.
I mean, you gotta have the rounded corners.
Well, it was more diag than a. It's that it thinks the screen is that size.
Yeah, no, I think the.
I assume the colors are.
Oh, I should kill Redshift.
Oh. yes, you should. So the Ustream app seems to be working. You can like Z-write JHuts and tell them to give it a try.
If someone could Z-write JHuts and tell them that Ustream seems to be working.
We have 0 viewers at this point, so
yeah.
it's.
And that didn't reset my gamma.
No, it's just slow. It's coming up.
Sure?
I thought it was. It looked like it was. It might have been my eyes. Certainly, I'm used to when I kill it, it cranks up slowly before it. I assume it didn't like kill line it or anything.
I kill-1 did.
Yeah, I think that's.
Whatever. I don't think it.
We don't have door props on these, huh?
Yeah, people know how to.
Some people that don't know how to open a door, we have much deeper problems. We have a more important cluedump to give. And with that context, I'm now reading this slide as the ziphy door notification system.
I wonder if the camera's doing auto white balance and canceling it out because the screen looks white on my phone.
Harold, it's definitely dumping brain dump stuff to log, and there's only one zephyr running in Casio, and it was launched correctly.
Okay, and what?
And it was launched correctly. And
Okay.
this proc environment for it shows the right stuff.
Okay, interesting.
It's still running in RC. Were there any changes between the last RC and the release?
Not relevantly, but like I'll take a look at it.
Okay. red dots. What is the origin of the sailboat made of dots?
The X-Cursor font had one, and my girlfriend liked sailboats.
Okay, that's a good reason, a good every reason.
And since I was spending a lot of late nights writing the client, I had to pick something. It's like, sure, we use a sailboat, and it just sort of stuck, and nobody questioned it. So.
Also wind.
Sure.
Yeah, except that a zephyr is a light breeze that basically wouldn't do anything. Wouldn't move a sailboat. Now, why there's a sailboat in the X-Cursor font is an entirely different unanswered question.
Why is there a snowman in Unicode?
So that unicodesnowman.4u.com can exist.
I think it's like approximately everything is in Unicode at this
Yes.
point.
The name of my Unicode tribute band is Snowman and the Heavy Black Heart.
That works. Actually, I haven't looked to see if there's a. There must be a sailboat in Unicode, but I haven't actually looked for it.
One moment, please.
Yeah, I knew I could just say that. I suppose then it will be a question of how many sailboats.
Character code point 26F5.
Sailboat.
Just sailboat, got it. Carl is now editing the presentation on the
The
fly.
real question is there a compose sequence for that comes with X? I'm not really sure what it would be, maybe caret and U, I don't know.
So it ends up as a completely blank character max.
I have I typically install TTF-star, although I think fonts-star
It
is
doesn't show up in my terminal either.
And the question is really whether it would show up in a web browser, but
In a web browser, yes. It's strictly being rendered in mine.
I just can't be bothered at this point.
Yeah, that's fine.
Post-presentation, so who was bringing over the snacks?
Presumably they would organize some people.
We should be arriving in 3, 2, 1. Did that work?
Somebody's at the door.
Not as well as one would hope, apparently.
I tried.
We were hoping someone could brought over the snacks, because I'm thirsty.
And so I started counting down that they should be arriving in 3, 2, 1, and then
The door
another 2
opens.
seconds later.
You don't have the high enough water content.
No, you should totally set up the snacks table. That way you'll be all set to eat them all.
I can't eat the snacks, so
Oh.
sit over here.
And you should probably sit closer to the front because we don't feel like shouting anyway.
If you're looking for a review session, I think it's in
237. If you're looking for Zephyr, you're in the right place.
Rather than 231.
I don't think you knew what room this was.
There was someone here when we got here who was just sort of camped out, and they're like, "Do you know where you are?" And apparently she had gotten an email saying it had moved to 237, but she didn't know
I
it.
hadn't realized that this was not 237.
Yeah.
Well, I think the problem is that the stairs to the back are labeled 237 because it's the back of the other half.
Fair enough.
People see the first door and think they're being clever.
Or the review session is just in the little anteroom there.
On the stairs.
On the stairs.
The expected attendance is quick.
Right. So you probably have more convincing clock than I do because
Oh, no, like.
My
it's-
watch just says 7:30.
Um,
16, 19, whatever.
yeah. I
Is
see.
that another 4 minutes?
And
Any of the snacks for the rest?
JHUTS hasn't actually signed in as far as I can tell, or at least Ustream isn't telling me is.
Oh, is that what's
So is this?
That's what I'm trying to do. We'll see if it does anything. But there was like an app, and I already had a Ustream account for something else. Probably snarking at
So are you
webcomics.
presenting or just Carl?
It's Carl's talk, but there are a bunch of things that need someone more bearded and old than he is, so I'll be chiming in at various points with.
How much notice do you need to grow a beard?
Pretty much infinite. Really, the stubble that I usually have is about as much as it gets.
Oh.
I mean, hair transplant or hormone treatments might also work.
to the garment district?
Which could totally get you both of those, right?
Well, no, but
No,
you did
well,
some advisory
no.
things, right, that were, you should shave your head and put on a pointy nose and be Groot, and have a scarf and be Groot. What?
No, I just had this image of Carl holding a minion and having it just explode. just sheer presence.
Me or the minion?
Well, the minion, I was thinking, but
What about my turtle?
There appears to be a turtle on your head.
Uh-huh.
Yes. That is all.
So the door closed at 7:29.
That would imply that someone has left with snacks.
No, that would imply that someone closed the door. Maybe they left. Maybe they
went
left
to the
with snacks.
bathroom.
Yeah.
Because they drank all of the sodas that were supposed to come with the snacks and had to go to the bathroom.
That's a lot of soda, I assume, for one person.
so they are waddling across campus.
Having roughly doubled their volume from liquid.
How will they do?
Also, why is this being so dark?
What?
It's so sad.
I mean, partially, I think it's just an old projector. Partially, it's the gamma is set wrong for the. I think my computer is a little confused.
I haven't actually tried to use Redshift with multiple screens before.
It does actually work.
I've used it with an external screen, but with two at once, there's like presumably some things to get ready.
Oh, we didn't actually add you to the list for tasks. There. Now you are on task C. I'm talking to Carl.
Yeah.
Also, you didn't answer my what?
Which what?
Much earlier. You like said 7 a.m. on November, and I was like, what?
Oh, right. You said you had to be you fixed before. Okay, cool. You said it had to be fixed before 7 a.m. The reservation had to be
Changed or canceled?
changed or canceled before 7 a.m. And you didn't say whether it was 7 a.m. tomorrow or in on November 3rd.
Oh, 7 a.m. on November 3rd. I
Nice.
thought that was implied.
People have actually been watching the city door monitor to see.
Okay.
So fueling Carl is appreciated.
More lubricating. But don't think about that.
Don't say that again.
Oh dear.
Some of it might explode a little bit, we just carry it over.
Just don't spray it on the no food break sign.
So here, maybe.
I like it. actually work with Carl these days. And, but I did startups. The reason I'm in it is because they bought one of my startups. We do a lot of software. Selling software for a year. The reason I'm here for this is Zephyr was something.
Yeah. What?
Parts of the story that are. Because I do this.
Of what? On a machine that's dead. But I can set you up.
But not later.
Yeah.
Yeah.
Ooh, we have one viewer. Hi, Jeffrey. Doesn't. There's a mute icon, but I think that means muted. Okay, unmuted. One viewer.
Are you like in charge of reporting back or something?
No, I was just curious.
There's tax also. Yeah. You do tax fishing? Whatever, I mean,
2:37.
Just every time the back door
Do
opens,
you know
we
what
just need
class
to
it
chime
is?
people.
I usually come in. I usually come in the back door. I don't know. I don't have enough reference to hang in the clock.
It was a study group for something, but she ran away when she realized that, so I didn't find out.
So it was not like a review session by a TA or something?
No, I think it is.
Oh, wow.
She said review session for, and then a relatively large number for.
Like 20 something?
No, I mean, it had a lot of digits.
Okay.
What?
So I
all
think you're
right, I think we're,
No.
I think we
what you're
gotta
saying
get
is
started.
Okay.
So I can introduce you guys because I have to. Welcome everyone to our second SIPI cluedump of the semester. We're going to be learning all about Zephyr, which is MIT's instant messaging system, or I guess chat client. We're going to get something more general than that.
We'll be going into the details as we go on, so.
Before we start, I'd like to mention an IAP class 6370, also known as Battle Code. This is a fun class. It involves coding and competing, and there are a lot of corporate sponsors and so on, so it's generally a pretty good time. So if you would like more information, I'll leave these up front. And without further ado, Carl and Eichen.
Hi.
Okay.
Hi, Carl.
This is about the Zephyr notification system, which I believe you are all familiar with. And the subtitle of the talk is how it works and how it doesn't. So first question you may be asking is, who are these people? I'm Carl Rahm. I am sort of somewhat socially and somewhat technically responsible for dragging dragging Zephyr into the 21st century by making it work with Curve 5. Although I have to give credit to Pascal Grunman, who at CMU, who also did a lot of the heavy lifting when it came to the cryptography and Kerberos.
And I'm Mark Eichen. Again, I worked on Zephyr originally as part of Project Athena. There were probably 6 or 7 of us on the team at the time. I did the original clients, which were all X10 clients, not X11. So you can at least mostly blame me for the scribe-like text formatting syntax and the sailboat icon. The sailboat's, I think, the only thing left that's in the current code.
It's still scribe-like, but
It's still scribe-like, but it's a completely different base of code than we started with.
really hope so, because the scribe formatting code in Swig C is really ugly. Okay. Yes. So.
Why are these people?
Oh, right, what we're talking about. It's like, a lot of this, of course, was done late last night, and I can't read the notes on this screen very well. So basically, we're going to talk about the protocol and how the system fits together. We're not planning on talking about the API, which is really horrible, and if you can avoid it, I recommend it. Or clients, which are not exactly multitudinous, but they've been expanding recently in interesting ways.
This would be a good chance to check out what our audience is. How many of you actually use Zephyr on a regular basis?
Right now?
You're right.
Yeah.
Okay, excellent. How many of you have contributed code to Zephyr at any point?
Zephyr specifically, or any of the Zephyr clients?
Count the clients, sure.
Technically.
Okay, so I was concerned that half of our audience would be people who could actually give this talk.
Don't
so
you have to raise your hand for that one, Jeff?
Fair enough. Pay attention.
Okay. So the Zephyr code base is 42,457 lines of code as of the 3.1 release. No one really understands it anymore. I'm not convinced anyone ever actually did understand all of it. So I'm sorry about that, but we mostly have a good idea of how it behaves. Assumptions for the rest of this talk include that you know what it's like. Everyone here knows what I mean by session key, right? And you're familiar with Kerberos enough to say that, you know, it via mathematics, it gives you a binary blob that you can present to another service to establish your identity. If you're not familiar with how the hows and whys of Kerberos, I highly recommend this, which my notes will be posted somewhere or after this, and you'll follow this link. But usually, if Google is indexing us this week, you can find it by Googling for Kerberos dialog. See, you guys, we're assuming that you know what IP is, and that you have a notion of what UDP is. And that you have at least some familiarity with the C type system.
And then we'll be throwing code up on the screen.
Well, not much. But.
Structure declarations.
Okay. This next slide is yours, Mark.
Okay. Yes. Wait, what was it like then? If you don't recognize the movie, ask us later because you really need to see it. As Carl was the one who pointed out in inspiration for this talk, that it really has been 13 iterations of Moore's Law since the Microvax 2. And that all of this was originally developed when we had BS2000s on our desks and Microvax 2s as servers. And that was because we were trying to move to physically smaller machines. The 11780s were also still in use as servers, and we're talking, dishwashers that your wristwatch would be embarrassed by computationally. Literally 1 million instructions a second, 4 meg of memory, 140 meg of disk, and that was a reasonable working environment. That was definitely, not maybe something people would be happy to have as a workstation at the time, but since we were just sort of inventing the concept of a reusable workstation, the fact that you could edit text on it and then you could run scribe and get your documents out and you could throw them over the network to a printer, which was also about that powerful, that's where we were, and people dealt with it pretty well. So some of the things, as Carl points out, some of the things from them will seem strange because, well, they were strange back then too, but a lot of things are just going to be strange because the assumptions were different. I mean, literally 4 megabytes of memory, if I had my phone there take a picture of the stage here, it would use more than that, right? The camera phone picture would take up more memory than the entire Zephyr server had in 1988. The other thing is, don't want to give the impression that I wrote all of this. I wrote, the first graphical clients, the first Wicca. I get the blame for that name also because that's the good name. There was a much worse name with similar set of letters that we had to censor at the time. But there were a bunch of watchmakers, as they were called, based on the Niven improving things by hacking on them, except they were of course paid by DEC and IBM. Tony Delaferro was the project lead, and he gets a lot of the design credit. Dave Jedlinski, responsible for the host manager. Rob French, responsible for, many of you may know from Square Dancing, because he comes back and does that a lot. But he's responsible for a lot of the library and a lot of the more sophisticated parts of the open wire protocol. Well, the packet reassembly and such, which was sophisticated at the time.
Advanced.
Anyway, enhanced, right?
Well, advanced.
And we have to give some credit to Jerry Saltzer first for trying to stop us, because Project Athena was a formal project, and there was a lot of, planning, and you may have seen the Project Athena technical plan from that period if you've been by the SIPI office. You should still have copies of it, collecting dust. But there was a lot of ambition for the whole project, and really, when you've got two big companies throwing these really big sacks of money at you, you want to be able to convince them that you're actually got a plan and you've got organized ideas of what you're going to do with all this money. And so Jerry Saltzer was technical director of the project, and he was basically adult supervision in a lot of ways. And a bunch of things about Zephyr went on behind his back, and when he found out about them, he wasn't terribly happy with them. And so at one side, having some oppression is always good for a project to get people a little more excited about it. It meant there was a lot of underground deployment in the early days, but then at the same time, once it got popular enough that it's like, okay, we have to make this part of the plan. It was instrumental in a bunch of design feedback and other things you might want to consider to actually do this right. I think that's most of the names. Bill Sommerfeld gets some credit as well, but he wasn't on the main development line. I think that's about it.
Yeah, I think that one notable comment is that there is actually the Project Athena technical plan that SIPI doesn't have the Zephyr chapter. There are copies. There are things that in the Zephyr locker that claim to be the Zephyr chapter of the technical plan, but Anyway, what Zephyr was ostensibly for was a notification service. It was not actually designed as a chat system. So you could find about when you got new mail, when your print job finished, your file server was going down. When there were new messages there were new messages in Discuss. Another thing I keep always forgetting, but
this is why it's called a notification system. It was about having machines talk to you, inform you of things. Communication wasn't, it's not messaging, it's not communication, it's notification. Which is why the whole model of having something that popped up a window with a message made perfect sense, because you would deal with this notification and then make it go away.
So it would notify it in modern terms. Now, what it wasn't was, a chat system. The things that modern chat systems provide that Zephyr doesn't even think about. Persistence, that doesn't keep track of the messages that you have received where you were out, unless you're actually running a client. Doesn't encrypt anything. Basically makes no attempt to hide your stuff from the NSA. No denial of service protection. No clients that work behind NATs. Oops. Anyway.
That's hadn't been invented yet.
So the sort of basic unit of a Zephyr description is a triplet. And you use that phrase a lot, or that word a lot. Something you can subscribe to or send a message to. Class, instance, and recipient. I'm still not entirely sure about the class and instance part.
Well, you look at these examples, right? Message isn't a good example, but filserv, the class of things which are file service related, and then the instances of that class, in this case Epimetheus is an example because it's a particular file server. And the idea is that, within a given class of services, you care about particular instances for whatever your use is. Discuss, again, an instance is a server and a path, because that's, one meeting is named, that's the name of the meeting. So if the meeting is going down for maintenance, you might also have multiple kinds of instances, like say you wanted to reach everyone who cared about that machine going down. Well, you'd say, okay, I have some meetings on this, I care about the meetings and I care about the machine. Again, the class would be discussed, the instance would be Menelaus or whatever. So that was where the idea of having the triplets at all came forth. class level was just, okay, we have a service that's gonna do a set of things, we have to hang a name off of it. And then, yeah, we have individual things within that we want to filter on. Message personal was just sort of a backdoor for things like, okay, we know this is a print job for a person, and we already had, there actually was a print class in here at the time, but it got in late enough that we're like, well, we just want the printers to do something here, we'll send it to some default that the user already has. And that turned out to be most of the traffic, so.
Okay. So you send a zephyrogram. Doesn't flow very well, does it? Anyway, it's cluedump, it's not a job top. So a zephyr message from the sort of higher level perspective, you have the class and the instance and the recipient. The recipient, I should have mentioned in the previous slide, is either either a particular recipient, particular entity, a single entity, or everybody who's subscribed to the class and instance. Messages have an opcode, which is which looks a lot like another freeform text field like class and instance. It's mostly not used by the user visible parts of Zephyr and used a lot in the except by convention, and it's used a lot in the innards of subscribing and setting your location and so forth. And of course, there's the message, which is a set of fields. In 99.999% of the traffic at this point, there's a Zephyr signature and the actual message. And sort of so everything above this line happens when when you're assembling a message to send, what you attach it. When you receive a message, it also has sender, who sent it, whether it was authenticated or not, when it was sent, and where it came from. Where it was sent and where it came from are sort of cheating in ways that I will describe later. But yeah, I mentioned opcodes. The convention for opcodes is there are basically only two conventions I can think of right off the top of my head. Where opcode ping is not displayed by your client most of the time, and it's used for Z-write and related functions to decide whether someone's listening on a instance or not. Although originally, there was at some point someone realized that half the message traffic was ping messages, and stopped sending the and so turned off ping by default on broadcast messages. Because there was in fact, the Zephyr servers were in fact doing a lot of work. Someone sent a ping message to a busy class, or a popular class rather, than it would send the hidden ping messages to everyone's client, which would then drop them on the floor.
Yeah, it was one of those early, really obvious features that nobody thought through, because the entire point of ping was that if you were typing Z-write, you might want to find out before you type your paragraph of message that, oh, no one's there, that individual isn't there. And so it got implemented for that purpose and nothing else. Everything else was just sort of a, oh, right, that doesn't scale, does it?
And as I said, they're used at the protocol level for things like subscribing and locating. Now, I'm cheating. I have this as the triplet here, and then the opcode in square brackets, which is sort of a private convention. I don't throw anything that you get by default actually uses that. That's one down. So the location and the location service, when you z-locate someone, this is almost entirely orthogonal to everything else that Zephyr does. It's almost a separate service that runs inside the Zephyr server, and I suspect you could actually, now that I think about it a little bit, I suspect you could actually separate it out completely.
Oh yeah. We've always talked about it as a sort of sidecar in that it isn't really part of the protocol, it's just this thing that happens to be on the server.
And in versions of the server before 3.0, it's really horribly implemented. And it's just amazing how nicer you can make the worst case of something just by using reality. But like I said, there's nothing magic about the location stuff. If you had a Z-write that could send, I think, 3 messages with three properly formatted fields, you could do all of Z-locate and Zigdal unhide and the Zigdal set exposure, or at least the protocol parts of them, with just a suitably flexible Zephyr client. This was a very short slide. I was going to say something. It was because someone told me that I should say something about Zigdal. And Zigdal basically is it's sort of it's roughly what I just described, except it's the flexibility is not actually flexible. It is something that can write local files when necessary, but really its sort of primary shtick is that it knows how to send these specially formatted zephyrgrams. And it's not ultimately doing much more than that.
Well, it does do a few things with like files.
Yeah,
sure.
Right. It writes things down, but like.
The other bit is that back then everything was a SS-based client, a sort of control tool. Because it was from the Multics model for command line interfaces. You had a command line interface with a set of subcommands that were basically verbs with some set of options. And enough of those got written under Multics that there was this whole subsystem library for it. You could just provide a declaration of what your command set looked like, and it would just call functions for it. SS under Unix was a low-rent clone of that by Ken Rayburn. And Discuss is the other thing that sort of still survives that uses it. But Zcodel used that because it was what you did. Then it was sort of what we had for that kind of functionality.
Although we actually, yes.
Yeah, it can.
And that might be all 3 of them. Yeah, that survive. The only other thing I can think of that you used it was all C.
Yeah. There was a lot of talk in the appropriate time period, I would say mid-90s, that once we had Tickle, we really should have switched to using that because it's great for building this kind of thing, and it has loops. So you can write more advanced functions in Tickle instead of having to write them in C. But that never actually happened.
And I just thought of another thing that uses it, which is MR test, and it's probably good you didn't switch to Tickle. Anyway, also I just feel worth mentioning. I think if it's a 302 or 303, you don't actually need. You can actually build Ziptel without SS. And I don't feel really bad about that because Ken Rayburn wrote the patch. Anyway, another chunk of the system that you have heard about is ZHM, Zephyr Host Manager, which really doesn't do very much. Exactly 2, maybe 3 is now that I think about it, not necessarily the best way to get the point across, but it keeps track of a server that's up, so when you type zwrite, you don't have to waste your time doing service discovery. And it acts as a retransmit queue. It doesn't do much else than that, except it tells the server when the workstation reboots, so to cancel all the subs there. In a sort of ZHM-less setup, you can imagine just doing that with zwrite or Zictal or something like that.
To give you an idea of where that came from, the original point of zwrite client, again, wasn't to be an end-user chat with your friends thing. It was specifically to be we have some new service that needs to send messages to the user, but we don't want to add an event loop to it, or we may not even be able to, but we can get it to run some hook that runs a shell command. So you don't have any persistence, so you can't keep track of what servers are actually up. Because remember, Zephyr has multiple servers, but the client takes care of the failover. It's not like there's a central load balancer or anything. There's just client knows about all of them and picks one, and if it gets an act, then it says, oh, I guess that one was good, and if not, it tries again, just round robins. And making some other service wait around for that every time. If the first of a set of 3 is always down, all of a sudden everyone has to wait for that to time out. So it made sense to move it into this auxiliary service that just sort of sat there on the machine. The retransmit queue, likewise, sometimes servers we were integrating in, we really didn't even want it to block waiting to say that the server got out. We just wanted to get the messages out in a hurry. For example, file server going down now because it just mounted the partition read-only. It's not your priority to actually tell everyone, but you want best effort. So the thing that's found out that something's wrong will just splat out all the messages and pray. And if some percentage of the users actually get them, we're ahead of the game. Again, that only works if something else already knows a server that's likely to be there. And the Z-write executable isn't going to know that. Canceling subs is just a privacy thing, really. Machine reboots, somebody else takes over, and oh look, there's Zephyr server still throwing messages at the previous user. It's sort of a convenient way to say, hey, don't do that. Not to be mistaken for actual privacy. Just
Right.
saying,
Reminds me of something I should have put on the notable bugs. Anyway, when you start a client, it subscribes. The subscription request goes to class Zephyr instance client to everyone, and with opcode subscribe, and it takes the message, the triplets that you're subscribing to, and puts them in fields in the message body. And I have the note that and sticks it in a Zephyrgram with it's authenticated, which is to say it has an authenticator in the relevant field, and this provides the Kerberos session and the session key that the server keeps track of.
Right. Because fundamentally, that's actually what subscription is about. It happens to also say what you want to get messages for. But from an implementation perspective, it's all about getting the authenticator, getting the original payload there, so you now have some shared state, maybe the session key.
Yeah, and once the servers received the subscription packet and looked at it and decided it's a valid subscription packet, it then hands it off to the other Zephyr servers, largely unmolested. Obviously, if the Zephyr server gets a subscription packet from another server, then it won't forward it on. But it uses this to keep a consistent subscription database across all of your servers. And there's some obvious places here where that can go wrong, which I'm just going to sort of point at and go, it doesn't happen most of the time. So yeah, when you send a message, once you have subscriptions and other people have subscriptions, the message delivery doesn't happen the way subscriptions do. Each server has a complete set of subscriptions and knows where all the messages are supposed to go. You send a message to the server, it goes okay, and then sends them to all the possible destinations. This is one of the problems that comes up when you're trying to think about how to make Zephyr work through a network address translator, because you have a relationship, at least some relationship with the server that you originally sent your subscription request to, but then these other machines start sending you messages that you didn't actually know about ahead of time. And they expect you to be coming from the same port that the other stuff came from. Actually, they expect you to be coming from the port that was in your subscription request, but that's mostly an implementation detail. Speaking of implementation details, what actually goes in into the packet. This looks a lot like the struct Z notice T, for the people who've actually looked at the code, but it's not. This is actually the what's in the packet. The Zephyr packet basically consists of strings, null terminated. When I say basically, I actually mean is. You have a version, the version, and then the number of fields in the header. And in a not modern Zephyr packet, that's everything up to the last thing here. I think the stuff that I haven't, I've alluded to but haven't mentioned, things I haven't mentioned at all, but include the UID. Every Zephyr packet gets or it's every Zephyr message and every Zephyr packet, I think, gets a unique ID. This is used to prevent for acknowledging things, to prevent replays, and ultimately to coordinate the fragmentation and reassembly. I alluded to the port. Each Zephyr has the UDP port number that it came from, ultimately. Then there's a flag that says whether we think that the message is supposed to be authentic, and then if it's then theoretically, if it's actually going to be, it's a Kerberos authenticator, appropriately encoded. The class, the instance, the opcode, the sender, and where it's going, and the so-called default format, which I'm going to say it's a text string for now and encoder sort of ignore. The checksum of the whole thing, what it's doing in the middle of the packet, is sort of an interesting question.
Oh, that's easy, actually. Multi-node just got added later.
Well, sure, but like, why is it between the, well, I mean, yes, it's obvious that the fragmentation and the reassembly is something that happened possibly after, or Salzer said, you might want to think about this a little bit, but why is the checksum in the middle of the message and not like, at the middle of the packet and not like at the end? There's a fair amount of C code, a fairly ugly C code written to, you have this chunk of the packet and this chunk of the packet, then you checksum it and you stick the checksum in the middle. But anyway, so then there's the ZUID of the sort of totality of a fragmented message, and then the address that it's coming from, but in a possibly ill thought out format with support for IPv6. So pre-Curb 5 versions of Zephyr, well, actually, I get that. And then there's an integer for the character set. Both of these were added by me, and I'm sorry for a variety of things. But so you'll notice that what's not in here is a timestamp or a origin address. And that's because a ZUID in the packet unique ID is actually an IPv4 address at a timestamp. This was like before anyone had any actual standards for universal unique IDs and so forth. So I mean, it's mostly actually unique. Although when you start getting people starting up a Zephyr client on random things behind NATs coming from 10.0.0.2 like this morning, it's sort of your desires about uniqueness sort of are reduced. Although the fact that there's a microsecond timer in there kind of helps a little bit. Okay, probably should have put this slide before that one. Yeah, I really should have. Anyway, but the important thing that was on here and that I didn't make clear is that you have the header and the body. Like I said, the whole packet is sort of null terminated strings, but only the first few are only the first 17 or so are the header. The subsequent null terminated strings are the message fields. And it's basically all the message fields, all the fields in the packet, in the message rather, that happen after the header field count. Now, I mentioned that there are a lot of numbers in that header, and I mentioned that that these were actually strings. In fact, usually, in the classic situation, they're human readable strings. Some of the I usually refer to it as NetASCII. Some of the documentation from the era refers to it as zephyr ASCII. But basically, you format things as hex numbers with the 0x and everything, and put them on the wire like that. So you would format them as this. You put a 0 at the end. The double quotes are supposed to signify that it's a C string. Now that I think about it, it was maybe not the best way of putting it, but whatever. 4919, for instance, x1337. And why I thought that was clever, I'm not sure. I guess it was late. That number turns into dead beef, and if you have something longer than just an integer, then like a Kerberos authenticator, then you would chop it up into 32-bit quantities and encode it as a bunch of integers. This is stunningly inefficient. Yeah. So this is.
Is it big endian or little endian? Anybody not wants to know?
So.
Yeah, mixed endian.
I think it's byte order, so it ends up being.
No, I think it's network. It's network wide. I think it ends up big endian, but like for instance if I read the code right last night, the characters are encoded in order. So this long string is actually binary string space separated 232-bit integers. So there would be an I, an N, and so forth.
So it's like wrong from an Indian perspective in that it's whatever your architecture is, it's a binary blob, and you put the digits in there. If you took out the 0x's and spaces, it would just be a hex encoding of memory, and minus the 0 padding, so you wouldn't be able to unambiguously disencode it, or unambiguously decode it. But really, there are a lot more things you could do to improve it than that, which is, I think, the next slide.
No, actually, it's anyway. So I mentioned fragmentation. Messages don't necessarily fit in a single packet. You have the multi-notice field, just two ASCII decimal numbers. Why I'm not entirely sure. Separated by a slash, offset in size. Notices are clamped at 400K. It used to be just enough to fit a Unix kernel into. You felt like sending people really big zephyr. I think we moved past that now. I'm not sure. Of course, the way things are designed, you can't fragment a header, and for some reason there's a 1024 limit on the packet. I've done some research. There is no network reason at the time why it had to be 1024 characters. Someone was being extra conservative. Like at MIT Net at the time was all Ethernet with a 1500 byte limit, or Proteon ProNet, which is with a 492 byte limit on packets.
The ProNet routers wouldn't crash when you sent large packets through the CDRAs.
So anyway, if you mix NetASCII and Kerberos 5, which with its like gargantuanly long authenticators, which only partially comes from the gargantuanly long key size, but like the fact that they decided to put everything into the authenticator, you're sad.
There was also lots of wrapping due to the encoding of the ASM1.
In particular, when ops or network updated the KDCs a few months ago, Zephyr was temporarily broken before they turned off some of the additional data that you could stick into a Kerb 5 authenticator, because the authenticator was just too damn big for packets.
And of course, having seen the hex encoding, we can't really point and laugh at ASM1, although we're going to anyway.
Right.
Well, you can always point and laugh at ASM1.
Right. So these days, to make Kerb 5 work, even before they started putting the authorization data in the tickets, we came up with this thing called Z code. which, the first character is Z, and you take the rest of the thing you're trying to encode and replace 0 bytes with OXFF, OXFO, and OXFF bytes with OXFF, OXF1. That's it. This makes it harder to read in a packet dump, but we're going to read the Kerberos authenticator anyway. And this actually has the flaw that the length is not actually predictable, which David Ben pointed out to me a few weeks ago, and yeah, I have to admit he does have a point. It does actually mean that there are unfortunate fudge factors that will cause problems occasionally. But I think I have a solution to that problem, which I'll get to later.
It's 2013 and you would just scan it twice.
No, actually, there's don't try and decode
Right, we don't have to design it either.
Right. So now I'm jumping around a little bit. I mentioned each server keeps a copy of the subscription database. Well, what if one of them crashes? Uses the so-called brain dump protocol, and I tried and I failed to find a good GIF for this that
was compatible with having food in the room.
Yeah, basically. So brain dump, the brain dump is it's roughly what you would expect. The server packs up all of its state and ships it to the new server. The only particularly interesting thing in there is that it does it over a TCP connection. It authenticates with Kerberos, all the good stuff, and encrypts it, and it sends the subscription request, location information. But the protocol it's using ultimately is Zephyr packets on a shoved over the TCP connection, using the same format as the normal subscription request, except I think the code at least used to have always put 7 sets of subscriptions in a packet, which if someone happened to be subscribed to a really, really, really long class name, would cause the brain dump to fail. And I think there's a notable bug, and I think I have a slide of notable bugs later, but I think we're ready to get this for the moment. Anyway.
Now, if you were designing this in a modern world, there are a lot of other things we would have done instead. One of the problems we ran into early on was you have 3 servers, right? That part's fine. You lose one of them, okay. Everybody notices and there's AHM start talking to the other 2. That's all good. The third one finishes rebooting, comes back up, says, "Hi, I'm here." Picks one of them and says, "Feed me." And then the brain dump starts. Because the brain dump requires a consistent database, well, it wasn't unreasonable the first time around to say just, okay, stop what we're doing, dump the whole database to the other machine, start up again, and at this point, we all catch up. The third server starts sending its updates to the 2 new ones, and it's all good. But at a certain size, by the time you're done brain dumping to that server, all of the clients have said, "Hey, I haven't seen you in very long," and they're all pointing to the third server, which has also given up on the first 2. And there was basically, at a certain user size, it just went completely catastrophic. It just sort of stopped working. You get around it by running with only one server for a while, but you have to fix the problem fairly quickly.
I think these days the distributed databases are an enough studied problem that you would just download one and use it. There's also the problem is what happens when you have a bug that actually knocks out all of them. And there's all of this stuff is in memory. It doesn't get written to disk. Maybe we would want to do that in a different way someday, but let's see, a security slide. I've alluded to a checksum. The checksum in the packet is actually a Kerberos checksum. You can use it to actually authenticate the packet if you already have the session key. At the moment, once you have the session key established with your subscriptions, the server doesn't bother to send you an authenticator. It just it just sends a checksum with that you can verify with the session key. And access control, I mean, none of this is encrypted, but the server does keep you from subscribing to things like the zephyr class, and limits how you can subscribe to these login messages. And you can actually put access control lists on arbitrary classes. For instance, no one here that I know of can subscribe to class ops.
And we saw the class instance breakdown before that is also the granularity of, you can do things at the class level and the class combined with instance level. That's an implementation detail, because after all, the server's the only thing that has to know about it. There's never been any real user visible part to that other than the MIT approach, which is everything's a Moira list, so Moira dumps to those ACLs, and we're done. To clarify on the message integrity point, note that when it says you can use that session key to verify the checksum, note that's the session key between you and the server. It doesn't do any end-to-end authentication. You authenticate the server uses that to go back and forth to you, but to any other user, it's between that user and the server, and you just sort of have to trust the server in the middle. Not that you didn't anyway, but knowing that's what you're doing is sometimes important.
Well, so the denial of service, obviously there's basically no flooding protection. Like that sort of thing is also always basically been on the level of you might be reasonably clever about it, but you have to be sending the packets from somewhere, and if you do it for long enough to be really annoying, people will find you, and you hope that the people who are actually working for the institute are the people who find you, because they're afraid of getting sued. There are a couple of obvious things which I'm going to sort of ignore I'm not sure I really want to say out loud. It occurred to me while I was working on some of these things, but there are a lot of stuff in the protocol where the server decides what to do based on the IP address. It has some obvious potential shortcomings, and I haven't given a lot of thought to how big holes those are. I mean, there might be ways where you can. The only things that I've really come with is like, oh, okay, you can get yourself asymmetric subscriptions. Oops. Although it occurs to me that if you're clever about that, you could use that to manufacture an alibi for something, but that's.
But in any case, this is the kind of thing where MIT is probably one of the biggest environments that is practical for, or some of the other universities where you've got a walled garden to the extent of, not in the sense of having firewalls, but in the sense of where your users live. This does not end up becoming practical as a replacement for something like AOL Instant Messenger, because all the things that do wrong here become much more of a problem at that scale. Whereas for small companies, startups, large companies, that's much more practical.
So the next thing on the list, the default format. I sort of skipped that. At least used to be. I think I can say that it used to be the case that Zephyr messages end up with a default format that gave your client hints about how to render it which is clever if you're getting a status message from a print server or from a discuss server or what have you. Unfortunately, for reasons which are a little bit beyond me, it included advice on how to format the sender and the class instance, and it was in the header as opposed to the message body, which means it wasn't fragmentable and it was taking up valuable space that we could use for our Kerberos authenticators. But this is on here, on the security page because of the formatting issue. And really, what were you thinking?
What we were thinking was that new services would come online that we would want to format and provide formats for new sorts of things. We had print service, we had just changed file server types, and so the idea was that new things could include a format that was reasonable and pretty, and you wouldn't have to roll out a new default wicked description file. to correspond to rolling out a new service. You just had to start sending the messages, and they would show up looking right. Very much back in the day we didn't care about buffer overruns either. You know, we knew everyone who was on the net, so we could basically trust them for that kind of thing. It lived a lot longer than it should have.
Yeah, I think that the encryption question was no, although I think what I wanted to allude to here was like there's basically no support for encryption in the protocol as it stands. There's their client convention, there's zcrypt, which for a long time was using DES in ECB mode. Someone just whimpered, which is a funny joke. Actually, I really should have had a picture of the penguin. Look up DES ECB mode sometime on Wikipedia.
Or just look at Des Penguin.
Sure.
It's still fine to think
Now,
about, right?
zcrypt at least, I think calls out to GPG now and can use actual crypto systems. It's not really visible on the screen, unfortunately. Later.
The other thing is that most of the ones that were old enough to use the problematic crypto also had buffer overrun bugs and could probably be remotely exploited. Although some of those did eventually get fixed. Some of them getting fixed is always a bad sign, because there are always more. Yeah. Trust, I alluded to a little bit earlier, which was that, like you said, when you're getting a message, all you've got is the session key. You can use the session key to verify the checksum. And in the obvious case, that does mean you're verifying it came from the server. But what does that really mean? It means that you're verifying that it came from someone who got your session key from the authenticator and was able to decrypt that. So yes, that means any of the Zephyr servers, but that also means anyone who might have that initial exchange where you sent the authenticator and the server's key tab. Now we protect those, but we also have government agencies that collect them. Likewise, since it is the session key, any compromise on the client side that exposes the session key that doesn't expose anything more dramatic, which is usually the case. Someone can totally print up a message with that session key and send it to you, and it will look authentic to you. And there are tools for this. I forget what they're called. Well, we call it a bunch of things, but that's actually useful in some circumstances when you're using your Zephyr client to do things like log yourself out from across campus, or do other things to the machine that you have Zephyr running on, because you can you can check that the message was authenticated and explicitly print the message up locally with that session key. So you don't have to go through the servers, you can send local messages that really are authenticated with that key. But that doesn't mean they're authenticated the way you might think of from the perspective of the whole system, because if you can print up any authenticated message locally, that means you can also print up that the message came from an arbitrary sender, right? So you really can't trust that a message was from the user in question. The most you can say is it was someone who had your session key, which is a bigger set of things than you might think when just looking at the mainline system. See also, you've got zcrypt. If you want to sign something, sign it. Because really, you can just send a PGP signed control message over Zephyr as well, and that should just work. ZHM botnet is a sort of different direction security perspective. This was somebody back in the early 90s who thought it was kind of cool that Zephyr was this messaging protocol that could distribute messages to a lot of machines. And he was I think, grad student who thought that, wow, we got all these clusters of machines, it'd be really cool to run shit on them. And so he went out and did this the hard way, made a modified ZHM that looked for a certain class instance, a certain triplet in any messages that came to it, and just sort of, just took the body of the command and ran it as ZHM. ZHM runs as root, but he didn't actually care about that part, which was sort of interesting. And so then he went around and deployed this to a bunch of machines by hand, but then once that was up and running, he could spray UDP packets across, various networks with, please run this, run this MATLAB job, except it was way before we had MATLAB. But, run this computation for me, compile this thing, and do it on all these machines, and then you could send it back the results, or you could send it a message to say, dump these results to this address, or whatever. I think he ended up spending a lot of time cleaning keyboards after we caught him because, well, he did walk around to all these machines and started out with the usual sin of installing it on one machine and then going to a machine nearby, logging in as himself and testing it. So, tracing that was basically trivial once it got to the attention of people who do that sort of thing. Intriguingly, because he had this nice command and control structure set up, ultimately what happened is, well, I wrote a tool that would scan for vulnerability and find it, handed that list off to Ops. Ops then took that tool, modified it to run the synchronize and re-update all your software, update workstation, basically script, and had it clean itself up from all these machines using the update workstation. So it was much less work, unusually, it was much less work to clean up the botnet than it was to deploy it in the first place. Probably the last time that happened. So, yeah, tempting target, even on a family campus.
So, in a realm, you're presumably aware of the people. This is where they come from. Requires a Kerberos shared key between the two realms. This is usually a showstopper for people who want to connect. Begin with, server knows the IP address. The servers know all the IP addresses of the foreign realm servers and handles those messages specially. The server essentially acts as the ZHM to talk to the foreign realm for the rest of us. Subscription, when you subscribe to a triplet in a foreign realm, they're forwarded for the requests are forwarded for an access check on the remote realm rather. But once you've done that, they only keep track that Athena has asked for these once, although it's been getting many requests. And once you have the subscription, the notices are forwarded only once per realm. Someone at 1ts.org sends a zephyrogram to an Athena class. It goes there. It goes to an Athena server, and the Athena server then sends out all the messages as appropriate. We have the n-squared connectivity problem. The servers realms can only talk to each other. They don't know how to talk to each other through each other, and the whole setup is a little bit fragile. Operational problems in a remote realm can cause operational problems in your realm. This should have gotten a little bit better with 3.1, but I think completely fixing it would involve monkeying around with the guts of Kerberos library. Let's see, notable bugs in that we've run. I've mentioned the header exhaustion problem. I've not mentioned that, and I mentioned the first and third one. The second one is that something that's actually fixed, once again fixed in 3.1, where if you were trying to send an authentic message from with Curve 5 Zephyr, the ZHM, and it didn't get ACT the first time around, ZHM would completely mangle the authenticator before it sent it out again. So if you ever noticed people occasionally being unauthentic for one message, that's what's causing it. If you've ever noticed that you were trying to subscribe to a lot of classes at once and then your subscriptions failed with the ServNAC, that's what was causing that. Kudos to Jeffrey Hutzelman for hunting that down and figuring out what was going on. Hi. Let's see, future plans, because all of these need to have the CMU people in long series of good ideas they've come up with said, well, why don't we just take the Kerberos authenticator and have a handshake before you use any subscriptions, and just put the whole authenticator in the message body. This basically means that no matter what the Kerberos consortium decides they want to put in the authenticator, as long as it's less than 400K, you should be able to authenticate. This also solves at least some of the Z code being difficult to predict in length problem, because you're just taking, you don't try to encode it all, you just put it in the body of the message and everything's fine. So I've actually implemented most of that, but it's not in a releasable state yet. In some much more future ideas, just changing the packet format to use Google protobufs and encrypting it with AES and some of the interesting AES modes that Mosh, if you're familiar with that, uses. I actually talked this all out with Alex Chernyakhovsky late one night, and because it was late one night, I've forgotten most of the details, other than it seemed to make sense at the time. And I really need to have that conversation again with him sometime, whether I can A, take notes, B, stay awake, and C, possibly have some caffeine. But it does seem doable. I think most of the tools are, if someone would just write the code to talk to a, I don't remember, Alex, do you remember what the set of buzzwords for a NAT that you can arrange in it's a universal plug and play internet gateway device.
Yeah, those are the ones.
Yeah, I think someone just needs to write the code, and I think we've been roughly that state for.
I remember discussing this at a party years ago.
Yeah. We probably should do IPv6 because it should be IPv6 should be widely deployed any day now.
Wouldn't IPv6 also make the NAT hosting thing a lot easier because you'd have to come up with a new UAE thing for IPv6 anyway?
So it turns out that the UID thing is in practice not much of a problem because people very rarely send messages in the same microsecond. But yeah, it would help.
Server sourced communication problem.
Yeah, the big problem. If it were just if UID collisions were the big problem, then we would be in happy land.
I didn't even just mean in terms of collisions. I mean in terms of the fact that everyone the UID is the IPv4 address.
Sure. Oh, so I think my original idea for getting there from here was take the last take the last 4 bytes of your IPv6 address and use that as your or actually no, it wasn't the last 4. It was the
It was
XOR all of them.
yeah, or something like that. Yeah.
Some obvious things
somehow collapsed the
I-
IPv6 address into an IPv4 space.
Yeah, I have this vague recollection of some way of doing it that didn't actually reveal your MAC address, but I don't remember. I figured
8-byte UUID, something.
Anyway, and Smart Realm, which is something that we've talked about, and Alex has occasionally threatened to go off and implement, and as yet hasn't, to basically solve the n-squared inter-realm problem. Is having if someone subs to a remote realm or tries to send a zephyr to a remote realm, the server goes, "Am I talking to this realm? No. Okay, I'll send it to George." And then you'd have George would be one realm that talks to all the other realms. This is by analogy to the internet email smart host approach, which I suspect is so ubiquitous that nobody calls it that anymore. Anyway.
I can see that I said I was going to work on that a year ago and then totally didn't. Maybe once I stop being absorbed by my latest terrible idea, I'll pick up a new one.
Anyway.
That's the reason.
I've done similar things for groundcentral.org would be awesome for this.
Yes. Sort of.
Wiki even says that.
Anyway.
I'm just kidding.
us about this stuff. Hillary wants to dig into stories you disbelieved or things about modern use of zephyr. Let's talk about. Now's the time. So we told you what up now.
The message format is a series of null-terminated strings. Strings go on forever. When do they stop?
What do you mean?
Message line.
Yeah.
There is an overall message line.
Well, sure. I mean, you have a, when you get the packet from the networking layer, it says, you know,
Gives you the length, right?
here is your pile of octets, and there are this many of them, and you can sort of work everything out from there. There was, in fact, a less notable bug, I think, I'm still not exactly quite. I don't remember exactly the circumstances where this would happen, but the server would something would produce messages that had junk after the something. Yeah, no, there's you would end up end up reassembling a packet with junk. Do you remember the?
So there were two bugs. The first bug is that when you do cross-run stuff, the realm that's receiving the message acts the message that gets sent. Because of a uninitialized memory problem somewhere, the sending realm would drop the packets on the floor, namely zone mid edu. In addition, when it went to retransmit, it also forgot the length of the message and dropped uninitialized data in there. And this ended up, in some cases, going through the reassembly code in interesting ways, but you still end up getting garbage at the end.
Right. So I forget where we started. That's where it ends. Yeah. Anyway, so we occasionally will lose track of where things ended. Anything else?
As you can see, people are still working on Zephyr, many of whom are in this room, but there are others elsewhere. CMU still has pretty heavy use of it.
Iowa State Zephyr Realm went away for a while, and it mysteriously came back, and I think it's been sort of intermittent. I'm not exactly sure what's going on there.
I'm trying to think of which other realms aren't vanity realms.
We used to see a bunch of traffic from Club CC, CMU, but that also seems to have dropped off.
And yeah, we get stuff from Andrew and CS separately.
Yeah, I don't think Andrew doesn't tend to deploy CHMs by default anymore.
Andrew is not deploying CHS by default. Right?
Yeah.
That was my understanding.
Did Stanford run one? Not that they talked to anyone ever.
I mean, other places that ran Zephyr, including but not limited to Stanford, I'm pretty sure. UMich definitely, NCSU.
Isn't Stanford the one with the weird lowercase whoever was wrong name?
Yes.
Is that anything?
Yes.
Well, and they have different ones, right? The V4, V5 realms have different names.
Yeah, that too.
And all sorts of excitement. So it was more sort of, they couldn't talk to anybody else because they couldn't like get anything to work anyway.
Okay, so that's because you talk to anyone else.
Yeah, they're just a little too strange to. Plus, there are isolated. Last I looked, non-authenticated versions internally at places like Akamai had a, I don't know if it still does, had a big internal Zephyr.
I think, yeah, using a non-Kerberos version.
Yeah, because that was where I got most of the bug reports on non-Kerberos builds back at one point.
The case I screwed Oracle still uses one internally, although it's authenticated because that was easier to install, I think, actually.
Yeah, I must admit, most of the times I got bug reports on the unauthenticated builds, and it's like, why do you actually want me to fix this? It's like, this is a warning, not a feature.
So we've talked a bunch about things that we can do to improve things like some of the deficiencies that you mentioned earlier, things like encryption and the weirdo message encoding and things like that. Any thoughts into fixing the persistence problem on the server side, or if we want to leave that to clients like Zulip and Bruce and Lloyd? I mean, it's not a completely unreasonable thing to ask, considering that's a feature that like every Jabber server does for multi-user chats.
Yeah, and I would even said that, a year ago, it was even, it sounded like an attractive feature that I was sort of thinking, how would I want to do this? But then I realized that from my point, the messages that are stored persistently can be subpoenaed,
Right, that's fair.
or NSL, really. So,
It's a feature, not a bug.
yeah.
Okay, but
Also, most of the multi-user chat functionality and the login and such could be implemented as a separate service. You know, the way login and presence could be, although it isn't actually.
along the lines of what you just mentioned, that's the theme level stuff, though, the current Zcrypt stuff doesn't have vertical secrecy, does it?
Doubt it.
No.
Which would surprise me if it did. I was kind of hoping that someone would tell me that, but.
Doesn't maintain any state and doesn't do any communication with the other end. You get
So you just have a symmetric key, and whoever possesses that shared key
Right. Yeah.
can read messages.
I mean, the other possibility for a model like that is use Zephyr for your rendezvous and communicate directly some other way. Whether that works in practice is now the net problem is your problem. But it has been used, at least for demos of protocols. We had a video chat that I think has been used to bust at least one patent, which is more use than it ever got as an actual protocol, where you could video chat between two next cubes by coordinating over Zephyr. Basically, you just, once you said, it would send a start video chat message, it gave you a port number and an IP address. And you're the client on the other side said, oh, okay, and opened the client and talked to it. And somebody tried to patent that sometime when video chat was actually practical.
That's more or less how the LMC messenger file transfer protocol worked originally, and that's why it never actually worked, because even then everyone was behind that.
Yeah.
And like and IRC DCC messages.
Yes, that also, same problem.
So there are a whole bunch of things that don't actually work. But the point is that you can do things with the rendezvous.
Does Zephyr actually predate IRC? I honestly don't.
Slightly.
Yeah.
So Zephyr is actually probably technically the first.
ICQ was older, wasn't it?
No.
Not ICQ, no, there was another one. Well,
So
BitNet chat was older.
BitNet relay.
BitNet relay.
So the older things are BitNet relay. There's the SMTP.
SAML.
Yes, SAML verb. So it's just basically a standard feature of mainframe operating systems that to be able to send users a message.
And in the BitNet relay case, we mean by that is throw a virtual punch card in their virtual reader.
Right.
One of the things about BitNet relay is it ran over BitNet, not over IP. And that was like the virtual punch card model. Just kind of scary to sometimes look under there, like, wait, they did that? That even went away a long time ago.
Yeah.
And yet.
Did you put the Zephyr homepage URL up on the screen?
No, not at all. That's a good.
Not
good.
that slide, or?
What?
It's not in the.
No, that would have been clever. I'll try and remember to put that in there for the this eventual slide posting.
Yeah, so you mentioned that it's slightly older than IRC, but how quickly did it gain momentum as a communication system instead of a notification system?
6 to 8 months.
Okay.
People are like that.
Yeah.
We concluded that it's just an emergent property of connected computers, that it doesn't matter what you're trying to communicate with, people will put messages in. In fact, Zephyr ended up that being, having the dog wagged by the tail in that sense was inevitable in retrospect. But yeah, that also got us a bunch more rapid deployment, because people were like, oh yeah, no, we don't want to test deploy, we want everyone to have it. So yeah, it really literally was a small number of months, especially because once people saw demos with clients, like, oh, I can pop up messages. Oh, I can send view messages. Using instances and classes very much were a slower thing. That took much longer. there was an initial, you could subscribe to message star because subscribing to a star instance was a feature of, say, file serve or discuss and the other classes. There were things where you wanted to know if any file server was going down or whatever. So that was in there for very early. But using it on message was just sort of a, oh, that works, huh? You know, people just started doing it once they caught it. And then going from there to classes was sort of a later generation. And some things are, moved. Personal classes sort of came out of that. And that was just a, oh, it's a sort of empty territory. If there's no ACL, then there's no ACL. So,
Yeah,
definitely.
Sorry.
No, go ahead.
The ACL mechanism as it exists right now is kind of funky. Any thought has there been any thought as to how we could, maybe improve that, have it be manipulable through the zephyr system instead of out of band, things like that?
Well, I mean, depends on, when you say kind of funky, like, I'm not sure what you mean there.
I meant clunky. I said clunky, sorry.
Clunky, sorry. But still,
It's files on Vista to be maintained individually on each server. I mean, that's kind of funky.
yeah, I've given some thought to that. I think I think widespread ACLing of classes would change things, and I'm really not sure how.
I mean, you already effectively have that with people using zcrypt and putting the keys on ACLs and AFS, but
Yeah. But that itself is a barrier to entry. The other thing, I thought about it. You probably end up something a lot more IRC-like. The other thing, at least in the Athena realm, is how do you decide who gets to ACL a class?
right.
And I thought, I have thought about setting up ACL classes for people in other realms, but never really done much of that.
Yeah, it seems like the kind of thing that would be easier to prototype outside Athena because the manage the files with Boiroc model works really well for Athena.
Yes.
So it seems like experimentation there is more likely to come from other places. Fortunately, we have other places.
Yeah, to some degree. So it occurs to me that Sippy itself should be on this slide, but it sort of is implicitly.
There's everyone.
Yeah. Another movie that you should really see if you haven't.
Yes, he's screaming, everyone. The professional, thank you.
What was the other
Very
movie?
slow down.
Dr. Banzai.
That's the other movie, Dr. Emilio Lizardo.
Or John Orphan, depending on your viewpoint.
Yes. Yes, in this scene, he's told them to bring the rest of the paramilitary and police type people. And the guy says, what, everyone? Everyone! And well, so we're crimping
Everyone.
a small portion of everyone. It's mostly recent everyone's. I'm probably the only first generation that's still involved in Zephyr at all. It's, Rob is airplanes to fly, and Dave is, we've got plenty of other things to do, mostly GNS productions and
Backlog.
yeah. Yeah, it's been interesting that it's been in active use since 1988 or so. Should probably advance to the
Oh, wow.
not screening slide.
Oh, okay. This has nothing to do with Zephyr. This is just something that will cause neurons to fire in sufficiently old people and pretty much no one else. But it's these are a set of features that you really want to have in pretty much everything.
Oh,
Someone gets
two viewers. I'm gonna shut down the session now, I think, because we're officially done. Thanks, Jeff.
Why not unlimited?
Where
How
we
many
put it.
bits can you process your address?
Well,
Well,
yeah,
at
no.
that point, it was what, 72?
No, only